Hi, today's video is going to be all about coordinate covalent bonds. It's not going to be a long one, but hopefully it's something that I explain reasonably well and you're able to pick up on. Now, a coordinate covalent bond is when one atom donates both electrons to make a bond. Now, this happens in the case where an atom cannot undergo what's called the expanded octet rule. Now, the expanded octet is something that I've done another video on, so you might want to have a look at that. But the expanded octet is where an atom goes beyond 8 electrons in its outer shell in order to bond with other atoms. Now, if an atom is in period 3, it can do that, okay? But if an atom is in period 2 and it wants to go and form more bonds than it would normally, it can't expand its octet because the second shell, which is the outer valence shell for an element in period 2, that can only hold 8 electrons. So in that case, what one of the atoms needs to do in period 2 is instead of expanding its octet, it needs to use some of its unpaired electrons to donate to create a bond with another atom. And that's called a coordinate covalent bond. So I'm going to show you a couple of examples of that. First thing I'm going to start with is a fairly straightforward one. I'm going to show you what happens with the molecule carbon monoxide. Okay? So with carbon monoxide, if we want to draw up how this would normally bond together, okay, I've done a video on drawing molecular structures where I show about how you draw electron dot structures, put them together, bond them up to create structures. So carbon is in group 4, so it has 4 electrons around it, like this. Oxygen is in group 6, and that has 6 electrons around it. Okay. Now the goal of both of these atoms, which are in group, so in period 2, is to get 8 electrons in their outer shell, because that's stable. So if we start bonding up our lone electrons, so we bond this one here from the carbon to the oxygen, and we bond this one here, sorry, I've done too many electrons on the oxygen here. If we bond this one over here, okay, what this means is that this oxygen over on this side has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So that's got 8 electrons. That's got a full outer shell. That oxygen is happy. That cannot get any more electrons in its outer shell because it's only got 2 electron shells and 8 is the maximum it can hold. However, the carbon over on this side has 1, 2, 3, 4, 5, 6 electrons on it. So this carbon doesn't have a full outer shell yet, which it wants to. However, oxygen can't have any more electrons in its outer shell. So if we were to bond up, say this electron over to here, so if we were to actually form a bond from here to here, what that would do was that would now add too many electrons into the shell of oxygen. Oxygen would now have 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons, which we can't have. Which means that we can't form a normal bond by sharing valence electrons in the outer shell from both atoms. So what that means that we need to do is instead we need to take this lone pair of electrons that we've got over here on the oxygen, and we're going to use both of those lone electrons there to create a bond over to the carbon. Okay? So those 2 electrons are going to form that bond. So we're donating both electrons from one atom to create a bond that wouldn't normally be there. So now what we end up with is carbon with a triple bond to an oxygen, and that's the structure, the formula we have for carbon monoxide, and that's how it exists with a carbon triple bond oxygen. We haven't increased the number of electrons around the oxygen. It still has 1, 2, 3, 4, 5, 6, 7, 8 electrons. The carbon now has 1, 2, 3, 4, 5, 6, plus these 2 overlapping in its valence shell. So it has 8 electrons as well, which is also happy. Sometimes what you'll see when you see coordinate covalent bonds drawn in textbooks or online is you might see them showing an arrow. So sometimes you might very weirdly see it with something like this, okay, an arrow showing that there's a coordinate covalent bond there, but we tend to have dropped that out these days and we just leave it with just a bond there as well, because it doesn't really matter whether it's a coordinate covalent bond or a normal bond, it's still just a covalent bond between the carbon and the oxygen. So I'm going to show you another one. So this one I'm going to show you, I'm going to do this time ozone, O3, which is a very, very important molecule, which is used to help block harmful UV rays from reaching the surface of the Earth. So the formula for ozone is O3, okay? So that O3 has 3 oxygens in it, so 1, 2, 3 like this, and we have 6 electrons around each of the oxygens, okay? So what that means is when an oxygen bonds to another oxygen, all right, we're going to get a bond there, and we're going to get a bond there. So that would be the oxygen molecule, okay? So we've got 8 electrons around each of these oxygens, they're both happy. However, if we want another oxygen to be able to come in to bond to this oxygen here, we don't want to get any more electrons around any of the oxygens, these two, because these have both got 8, so they're quite happy. So what happens again is this lone pair of electrons on this oxygen, they donate over to this oxygen to form a coordinate covalent bond. What that means is that this oxygen now has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it, which is happy. This one in the middle still only has 8 electrons around it, which is also happy. Because we have a lone pair of electrons here on this central oxygen, they're going to repel the bonded electrons downwards, and we're going to end up with a shape. It looks like this. So we've got an oxygen, double bond oxygen, and then we've got a coordinate covalent bond over to this oxygen over here. We've still got the lone pair of electrons at the top here, which overall gives that a V shape. So it's not too much different from drawing your normal molecules. The main difference is that one atom donates both electrons to make a bond, and that occurs when you've got period 2 elements that can't expand their octet. There is another video, as I said, on expanded octets, which I suggest you have a look at, just so you can see why something like sulfur wouldn't need to form a coordinate covalent bond, but something like oxygen and nitrogen do need to form coordinate covalent bonds. Alright, hopefully this has been pretty straightforward. As always, if you've got any questions, just ask. And if you've got any suggestions for other videos you'd like me to do, please put that in the comments below as well. Thanks, guys.